thank you, Prasanth especially, for inviting me to this amazing, me and my microbes, to this amazing celebration. So imagine a huge rocket that is capable of lofting satellites 23,000 miles above the Earth to look back at the Earth and to look back at what we are doing to our planet, our environment, our atmosphere, and even us, land masses, water, oceans, temperatures. Imagine this huge rocket. Is 3 rockets strapped together. There's 27 rocket engines. They all have to work perfectly. Imagine this launch. 2 of those rockets finish lofting, getting the rocket up to speed. 2 of those rockets actually turn around and fly back and land back on Earth to be used again, while the middle rocket goes off and brings the payloads up to orbit. When will that happen? The last time it happened was this morning. Now, imagine the largest rocket built by the United States, larger than the Saturn V that took the Apollo missions to the moon. To be able to go to the moon where to learn about things we didn't know in the 60s, there's water there. And eventually to Mars, there's water there. Where water is, we can do many things. Humans can do many things. The point is not to go to space to develop these technologies to use in space, but to learn things and develop toolboxes and to teach students, our graduate students and our undergraduates and ourselves, about how to make this life more survivable, more in tune with the environment, the one environment that we inherited, and to learn to live beyond the threats that we are generating ourselves. This is what the space program is for. So imagine this huge rocket able to go to the moon. It has giant rocket engines. It has 9 huge rocket engines, and it's going to go 243,000 miles to the moon and return with a capsule that can carry humans later, return to the Earth. When will this happen? In 13 days. 13 days from now. Now, imagine the biggest rocket ever built by the human race, able to carry vast amounts of mass and humanity into space, to learn about humanity in space, physiology, people in space, to be able to loft bases to the lunar surface so we can learn yet more about these things that we have such a hunger and need to learn about. This rocket is a monster. It has, in the first stage alone, 36 rocket engines, each of 500,000 pounds of thrust. This is science fiction. When will this happen? By the end of this year, the SpaceX Starship. And imagine people living in space for 22 years, crews swapping in and out on a spaceship that has international crews coming from many, many backgrounds over 22 years. Every single astronaut and crew member came back safe and alive and healthy to learn about what happens to humans in very hazardous environments, to learn about how to extract carbon dioxide from the air, to learn about how to reuse the water that we have already used, to learn about the kind of things that we need here. Imagine doing that for 22 years. When will that happen? Well, year 23 of that on the International Space Station started this week. That's just today. Let's talk about the future. So imagine you are in space, and you have been for 4 months on the way to Mars from lunar orbit. And as simple as that sounds, well, it doesn't sound very simple to me, but actually there's a lot of things that we don't know about that. What are the long-term health effects on your body? Zero gravity affects many aspects of your physiology, much like aging here on Earth. Long duration exposure to low-dose radiation. We have much to learn about that. Influences of fluid shift on your ocular properties, your renal system, and of course your muscular, skeletal, and vestibular system. So much to learn. What are the mental health aspects and the challenges from long duration isolation? Imagine being away from Earth for 3 years. You know, one thing about being in space, I can tell you, is the fact that you can see the Earth brings mental health into your being. And as soon as you are beyond, you know, when the Earth is just a dot, when we look up, when we see Mars, you know, you have to look hard. You have to know where it is. And if you saw Earth like that, it would not bring that sense of home back to you. What kind of countermeasures for these challenges? Now, I'm talking engineering, pharmaceutical, behavioral, and so on, can we develop that will benefit you, the space explorer, but more importantly, us, the everyday humans on Earth? So imagine that you share control of your spacecraft with an AI-enhanced control system that are learning all the time to monitor the subsystems of your habitat, the thing you're depending on to live, predict future failures, and build new parts as needed through additive manufacturing. How will you understand what the AI systems are doing, and how will you know when to intercede? Imagine if you have a team of robots on board to assist you and your crewmates in maintaining the spacecraft that your life depends on, reconfiguring it as things change, and repairing things as needed. How much can and should the robots do versus you and your fellow humans? Should you work together with the robots, share responsibilities, or should you have direct command of what the robots do? How can you remain safe when the robots are moving under their own autonomous control? How will you understand what they intend to do? And then, when surprise failures occur, and let me tell you they do in space, how will you or the onboard autonomous systems know what to do next? This is where humans really come in. What skills must you have before you launch to ensure that you're ready for anything that happens? And then, how do you say that about the artificial intelligence systems? Are they ready for safety critical surprises? Because it's going to happen. How will you know if they aren't? So here at UC Davis, we have the Center for Spaceflight Research. And we are integrating the frontiers of a broad range of disciplines because it takes them all. Everything is going on at UC Davis. It takes to do spaceflight safely and productively. Education, all disciplines of engineering, human physiology, neuroscience, behavioral psychology, human-machine collaboration, and so on, to answer the kind of questions I've just been asking and so many more, but more importantly, ask the future questions that will both enable the human exploration of hazardous environments and bring back to all of us the life enhancements that we really need. So we are the first generation of humans that could both ask and answer questions like this. So I hope you'll join me in this fascinating journey. Thank you.